Azure Resource Manager, or ARM, is something most developers use every day without realizing it. It is the layer that sits between you and every Azure service. When you click Create Virtual Machine in the portal, you are sending a request to ARM. When you run an Azure CLI command, ARM processes it. When your CI/CD pipeline deploys infrastructure, ARM is handling it. Every single management operation in Azure create, read, update, delete flows through the ARM layer first. Think of ARM as the traffic controller for your Azure environment. Before any request reaches the actual service like the virtual machine service or the storage service, ARM intercepts it, authenticates it, checks your permissions using RBAC, applies any locks or policies, logs the operation, and then passes it to the right service. ARM was introduced in 2014 to replace Azure's earlier management model called Azure Service Manager or ASM. The old model was inconsistent, hard to automate, and had no unified way to manage related resources. ARM solved all of those problems and is now the foundation that every Azure feature is built on top of. Let me walk you through exactly what happens when you create a resource in Azure, because understanding this flow explains a lot of Azure behavior that can otherwise seem mysterious. You submit a request through the portal, CLI, or REST API. That request hits the ARM endpoint at management.azure.com. ARM immediately validates your identity token from Entra ID. If you are not authenticated, the request is rejected right here. Next, ARM checks your RBAC permissions. Do you have the right role to perform this action on this resource? If not, rejected. ARM then checks Azure policy. Has your organization defined any policies that would deny this kind of resource in this region? For example, a policy that says virtual machines must use managed disks only. If your request violates that policy, rejected. ARM also checks resource locks. If someone has placed a delete lock on a resource group, ARM will refuse any delete operations on resources inside it, regardless of your permissions. If all checks pass, ARM routes the request to the appropriate resource provider for a VM that is Microsoft.compute. The provider creates the resource and returns the result. ARM logs the entire operation to the activity log, giving you a full audit trail of everything that happened in your subscription. Azure organizes its services into resource providers. Each resource provider is responsible for a specific category of resources and exposes an API that ARM calls to manage those resources. The naming convention is always Microsoft.something. Microsoft.compute handles virtual machines, virtual machine scale sets, and managed disks. Microsoft.storage handles storage accounts and all storage features. Microsoft.network handles virtual networks, subnets, load balancers, network interfaces, and public IP addresses. Microsoft.web handles app service plans and web apps. Microsoft.SQL handles Azure SQL databases and servers. Each resource provider exposes resource types. For example, Microsoft.compute has the resource type virtual machines, which is what you reference when deploying a VM in a template. Before you can create resources from a provider, that provider must be registered with your subscription. Most common providers are registered automatically when you first use them. But occasionally, especially with newer or specialized services, you will see an error saying the resource provider is not registered. You can register it in the portal under Subscriptions, then Resource Providers, or with a single Azure CLI command. ARM templates are how you define your Azure infrastructure as code. Instead of clicking through the portal every time you need to set up an environment, you write a JSON file that describes the resources you want, and ARM creates them. The key concept is declarative infrastructure. You do not write step-by-step instructions. You describe the desired end state. I want a storage account with these settings, a virtual machine of this size, a virtual network with these subnets, and ARM works out how to make that happen. If a resource already exists, ARM checks whether it matches your declaration and only updates what is different. The practical benefits are significant. First, repeatability. You create a development environment once, write the template, and then use the same template to create an identical staging and production environment. No manual steps, no drift between environments, no forgotten configuration. Second, version control. ARM templates are just JSON files. You commit them to your Git repository. Every change is tracked. You can review infrastructure changes in pull requests the same way you review code changes. You can roll back to a previous state. Infrastructure becomes auditable and collaborative, just like application code. Let me walk through the structure of an ARM template so you know exactly what each section does. Every ARM template is a JSON file with a specific structure. At the top you have the $sign schema field, which points to the JSON schema definition for ARM templates. This is just a reference that tells tools and validators what format to expect. You copy it from documentation. The content version field is your own version number for the template. Use something like 1.0.0.0. This is not enforced by ARM, it is for your own tracking. Parameters is where you define inputs. You declare a parameter with a name, a type string, integer, boolean, array, object, an optional default value, and an optional description. When you deploy the template, you provide values for parameters. This is what makes templates reusable. Same template, different parameter values for different environments. Variables are calculated values you define once and reuse. For example, you might combine a base name parameter and an environment parameter into a full resource name, shop API prod. Defining this as a variable means you reference it in many places but maintain it in one. Resources is the core section. This is where you list every Azure resource you want to create, with its type, location, properties, and dependencies. Outputs is where you return values after deployment, like the public IP address of a newly created load balancer. Let me make parameters, variables, and outputs concrete with practical examples you will actually use. Parameters are the interface to your template. Typical parameters include environment dev, staging, or prod, the Azure region to deploy to, and the application name. You declare them at the top and fill in their values either interactively or via a parameters file. A parameters file is a separate JSON file that contains the specific values for a given environment. You maintain one parameters file per environment: shop.dev.params.json, shop.prod.params.json. Variables solve the repetition problem. If your application name is shop API and your environment is prod, you probably want to name your storage account shop API prod and your web app shop API prod app and your database shop API prod DB. Define the base combination once as a variable and reference it everywhere. Change the environment parameter and every resource name updates consistently. Dependencies matter because some resources must exist before others can. A network interface depends on the virtual network. A VM depends on the network interface. You use the depends on property or the reference function to tell ARM about these relationships. ARM then creates resources in the correct order automatically, parallelizing where possible. Outputs are how you pass information back to whatever called the deployment, like a pipeline step that needs the URL of the newly deployed app service. There are several ways to deploy an ARM template, and the right method depends on your workflow. The Azure portal has a built-in template deployment experience. Search for Deploy a custom template in the portal search bar. You can paste your JSON directly, upload a file, or choose from a gallery of Microsoft Quick Start templates. This is the easiest way to test a template or do a one-off deployment. Not suitable for automated environments but excellent for learning. The Azure CLI is the most developer-friendly option. One command, AZ deployment group create, specifying the resource group and a path to your template file. Add a corresponding parameters file with the flag resource group and you have a fully parameterized deployment. You can run AZ deployment group validate first. This sends your template to ARM for validation without actually creating anything. It catches syntax errors, invalid property values, and permission issues before spending any money. For pipelines, both Azure DevOps and GitHub Actions have first-class support for ARM template deployments. Azure DevOps has an ARM template deployment task you add to your pipeline YAML. GitHub Actions has the Azure/ARM deploy action. These integrate with your service principal or managed identity for authentication, making fully automated infrastructure deployment straightforward. If you find ARM template JSON verbose and repetitive, and most developers do, Microsoft created Bicep as a better way to write the same infrastructure definitions. Bicep is a domain-specific language that compiles down to ARM JSON. When you deploy a Bicep file, the Azure CLI transpiles it to JSON and submits it to ARM just like a normal template. So everything you know about ARM parameters, variables, resources, outputs, deployment modes applies equally to Bicep. The underlying engine is identical. Only the syntax changes. The difference in developer experience is significant. An ARM JSON template for a simple storage account might be 60 lines of JSON. The equivalent Bicep is about 8 lines, clearly readable. Bicep has proper type checking, modules for reusability, an excellent Visual Studio Code extension with auto-completion and inline documentation. Microsoft themselves recommend Bicep for all new projects. ARM JSON is still fully supported and not going anywhere. There are millions of existing ARM templates in the wild. But for anything new, Bicep is the cleaner choice. In topic 39 of this series, we dedicate an entire video to Bicep in depth. For now, just know that if you see Bicep in the wild, it is ARM templates with better syntax. Two concepts that new ARM users often do not fully understand are idempotency and deployment modes, and both have practical consequences. Idempotency means that running the same ARM template with the same parameters twice produces the same result as running it once. ARM does not blindly try to create resources on every deployment. It checks what already exists, compares to your template, and only applies changes. If a storage account with the right name and settings already exists, ARM leaves it alone. This makes it safe to include template deployments in automated pipelines that run on every code merge. No risk of creating duplicate resources or errors because something already exists. Deployment modes control what ARM does with resources that exist in the resource group but are not in your template. Incremental mode, which is the default, will only add new resources or update existing ones to match the template. Resources in the resource group that are not in the template are left completely untouched. Complete mode enforces the exact state described in the template. If your resource group contains a resource that is not declared in the template, ARM will delete it. This is powerful for maintaining a clean, well-defined environment, but be extremely careful. Running a complete mode deployment with an incomplete template will delete real resources. Always validate and test with incremental mode first. Let me bring this topic together with the key takeaways and best practices. Azure Resource Manager is the foundation everything else in Azure is built on. Every operation create, update, delete, list flows through ARM. Understanding this layer helps you make sense of error messages, permissions problems, and why certain operations behave the way they do. ARM templates let you define infrastructure as code. Declarative, repeatable, version controlled. Write once, deploy to dev, staging, and prod identically. If your infrastructure is not in code, it is a manual process waiting to go wrong. For new projects, use Bicep instead of raw ARM JSON. The compilation step is transparent, the syntax is dramatically cleaner, and VS Code support is excellent. Best practices: always store templates in Git alongside your application code. Use parameter files per environment instead of hard-coding values. Always run validate before a production deployment. Use incremental mode by default and reserve complete mode for tightly controlled environments. Tag every resource in your template. You will thank yourself during cost analysis. In topic 7 we go hands-on with the Azure CLI and PowerShell. These are the two command line tools you will use daily to manage Azure resources, deploy templates, and automate everything that the portal is too slow for. See you in the next video. Here is your knowledge check for topic 6. Pause the video now and think about it. You deploy an ARM template twice with identical parameters. On the second run, the resource already exists in Azure with the exact same configuration. What does ARM do? The answer is, nothing changes. ARM is idempotent. It compares the desired state in your template with the current state in Azure. If they match, no action is taken. No duplicate resources, no errors, no unnecessary updates. This is what makes it safe to run ARM deployments inside automated pipelines on every code push. This is fundamentally different from writing a script that calls azvm create. If you run that script twice, the second run fails because the resource already exists. ARM templates always converge to the desired state, however many times you run them. See you in topic 7.